Good morning, friends. Today we will discuss another very important topic, which is time and distance. Time and distance is very important topic. We frequently get a lot of questions on this topic, and students unnecessarily get confused here. This is very easy topic. I'll explain. I'll explain with some very important problems. Right. There is only one formula in this topic, which is distance is equal to speed into time. That is the only formula that we need to remember. Distance is equal to speed into time. Whatever is the distance is speed into time. For example, I can travel at 50 kilometers per hour and I travel 5 hours. What does that mean? That means my distance I can travel is that I will travel is 50 kilometers per hour into 5 hours, 50 into 5, 250 kilometers. This is the distance that I travel. Right. I can travel at 40 kilometers per hour and I traveled 200 kilometers. What does that mean? I took 5 hours. 5 hours, each hour 40 kilometers. So distance is equal to speed into time. That is the only equation that we need, only formula that we need in this chapter, time and distance. Okay. With that, let's go ahead. Let's try to solve some basic problems. A dog takes 4 leaps for every 5 leaps of a hare. Okay. In the time a hare takes 5 leaps, dog will take 4 leaps. Very good. Okay. Then, but 3 leaps of a dog are equal to 4 leaps of the hare. Right. 3 leaps of a dog are equal to 4 leaps of the hare. That means whose leap is bigger? Dog's leap is bigger. Right. 3 leaps of a dog is equal to 4 leaps of a hare. Whatever distance hare covers in 4 leaps, dog will cover in 3 leaps. Right. So that means each leap of a dog is bigger than each leap of the hare. Right. So 3 leaps of a dog is equal to 4 leaps of the hare. Both, let's say both cover 10 feet. Dog will cover 10 feet in 3 leaps, and the hare will cover 10 feet in 4 leaps. Right. So what does that mean? Each leap of dog is equal to 4 by 3 times of leap of hare. What does that mean? Each leap of hare is, let's say if it is 1 meter, 1 meter can jump, a hare can jump 1 meter, then dog can jump 4 by 3 meters. 4 by 3 into wow, 4 by 3 into 1, which is 1 by 3 meters. Right. Dog's leap is bigger. Okay. Now what is he saying? He is saying one more thing. In a given time, a dog takes 4 leaps for every 5 leaps of a hare. Right. In a time T, a dog will take 4 leaps, 4 leaps, while a hare will take, while a hare will take, uh, while a hare will take 5 leaps. Right. So dog will take 4 leaps and hare will take 5 leaps. So now each leap is leap of hare is, let's denote it as leap LH. Subscript H. Okay, LH. That means in time T, how many leaps? In time T, let's say T is equal to 1. In one in 1 second, let's say in 1 second or in 1 minute, whatever it is, in 1 minute, how much distance a hare will do? Hare will do 5 leaps, right? 5 into each leap of h. Okay, 5 into leap of h in a unit time. Okay, in a unit time, let's be it be 1 minute, be it be 10 minutes, whatever. Okay, let's assume um, here is taking 5 into that 5 leaps, that is 5 into L of H. Let's assume each leaps, this thing is the distance covered is 1 meter. That means it becomes 5 meters, right? Then the distance covered by dog in that same time is 4 times leaps of dogs, right? 4 times leaps of dogs. A dog will take 4 leaps for every 5 leaps. 4 leaps, 5 leaps is let's assume it's in the same time period, right? Then a leap is doing 5 leaps. Sorry, a hare is doing 5 leaps, and a dog is doing 4 leaps of the dog. This is 5 leaps of the hare. 4 leaps of the dog is equal to 4 into uh, leap of the dog is equal to, we had discussed, 4 by 3 of leap of hare, right? Leap of hare, let's assume 1 meter, leap of dog will be 4 by 3 meters, right? Then a dog will cover 16 by 3 meters, right? In a given time, if a hare is covering 5 meters, if hare is covering 5 meters, a dog is covering 16 by 3 meters. You understood this, right? What we had done 3 leaps of a dog is equal to 4 leaps of the hare. That means each leap of a dog is 4 by 3 times of leap of hare. We assume the leap of hare is equal to 1 meter, then leap of dog will become 4 by 3 meters. Now, in the same time, hare is taking 5 leaps. Each leap is 1 meter. In the given time, then the dog hare is taking distance covered by hare is 5 meters. In the same time, dog is taking 4 leaps. 4 leaps of the dog is equal to 4 into 4 by 3 leaps of hare. 4 into 4 by 3 meters. 4 into 4 by 3 meters. Right, one leap of dog is equal to 4 by 3 meters. Because the leap of hare, we assume it is 1 meter. So a dog is covering 16 by 3 meters. Right. Dog is covering 16 by 3 meters in a given time, and hare is covering 5 meters in a given time. What is the speed of dog by speed of hare? It is equal to whatever is the same time is same, right? Speed of dog and speed of hare, the time is same. That means it will be equal to whatever distance covered by dog by distance covered by hare in the same time. That is 16 by 3 by 5, which is equal to 16 by 15. Right? You understood this, right? So here, please note that here it is, this first part is giving the speed. The second part, you have to use it to calculate what is the distance. Right? In all these problems, what I suggest you is, you first try to solve this problem. Don't look into the solution. You first try to solve the problem yourself, and then only get into the solution. That is the best way. If you are not doing that, the second best way is, at least after reading the solution, you do it yourself again. You have to do this. Otherwise, you will not remember. The best way is doing it yourself and then looking at the solution. That is the that is the best way. If that is not happening, at least after reading the solution, then you do it yourself. Then, second question. A man traveled from the village to the post office at the rate of 25 kilometers per hour and walked back at the rate of 4 kilometers per hour. The whole journey took 5 hours 48 minutes. Find the distance from the post office from the village. He walked one side and at a he traveled one side at a speed of 25 kilometers per hour and walked back at a speed of 4 kilometers per hour. What is the time taken for the forward? Let's assume x is the distance from village to the post office. So for forward, it is taking distance by speed, x by 25 kilometers per hour. Okay, this is the time for forward. And what is the time for backward? He walked back at 4 kilometers per hour, right? So same distance, right? Forward distance is equal to backward distance, right? So x by 4, x kilometers distance and 4 kilometers per hour speed. Let's say if this is 20, x is 20, then he would have taken 5 hours. Each hour he would have traveled 4 kilometers. X is 40, the distance is 40, would have taken 10 hours, like that. So X is same in both the cases. So forward, he had traveled at 25 kilometers per hour. The reverse, he traveled at 4 kilometers per hour. So the total time will be X by 25, which is forward time, plus X by 4, which is the reverse time, is equal to his saying what? 5 hours, 45 minutes. What is 45 minutes? 45 minutes is 5 hours, 48 minutes. What is 48 minutes? 48 minutes is equal to 48 by 60 hours, right? 48 by 60 hours, right? 48 minutes equal to, right? How many hours? 48 by 60, which is equal to 4 by 5. 12 goes 4 times, 12 goes 5 times, right? So what that means, 5 hours, 48 minutes is equal to 5 hours, 4 by 5 hours, right? This is the total distance. Total distance is 2x. Let's assume to forward is x, reverse is also x, total is 2x. Now, what does this mean? X by 25 plus x by 4, which is equal to x into 29 by 100 is equal to 5, 4 by 5. What is this? This is also 29 by 5. What does that mean? X is equal to 29, 29 will get cancelled, is equal to 100 by 5, is equal to 20 kilometers. So distance, one side distance is 20 kilometers. So it's traveling 20 plus 20, 40 kilometers. Right. The trick is to be able to write this equation. Time forward plus time backward is equal to total time. Time forward is distance by speed of forward. Time backward is distance by speed of backward. Right. Next one. Walking at 5 by 6th of his usual speed, a train is 2 minutes, 10 minutes too late. Find its usual time to cover the journey. Okay. So if it was traveling at time t, it would have arrived. It was generally arriving right in time. But if it is speed has reduced, then the time taken is 10 minutes more. Okay. So this distance is same, right? In the original time and original speed versus 5 by 6th of the time and 10 minutes late. So what does that mean? If 5 by 6th of the original speed. Okay. So this let's assume speed 1 and speed 2. Okay, in the original speed, let's assume it is taking t1 time. Speed 1 into t1 is equal to, in the second class, train is 10 minutes late. That what does that mean? That means train is taking 10 minutes more to reach the station. Right, so t1 plus 10 into, what is the second speed? Second speed is 5 by 6 of the usual speed. 5 by 6 of s1. S1 is the original speed, t1 is the original time. So T1 into S1, that is the distance that a train is traveling speed at speed 1 for T1 time is equal to the distance it is traveling at 5 by 6 S1 speed. The speed is slower and the time is taking 10 minutes more. Right. T1 into S1, the speed at which the train was originally traveling into the time it was taking originally when it was not late is equal to the additional time. The new time is 10 minutes more. So T1 plus 10 and new speed is 5 by 6 into S1. So T1 S1 is equal to 5 by 6 T1 S1 plus 50 by 6 X1. Right. What does that mean? 1 by 6 T1 S1 is equal to 50 by 6 S1. Right. What does that mean? Cancel 6 here. T1 is equal to 50. T1 is equal to 50. What does that mean? T2 is equal to 60. Right. Because 5 by 6 of the usual speed. So T1 is equal to 50. We can substitute and we will get T2 is equal to 60. See, what he's saying earlier, the train is taking 50 minutes. Right. It is taking 50 minutes. Now it is taking 60 minutes. Okay. Let's see, we'll discuss this once again. Otherwise, let me keep it simple. The train, it used to take some speed. It used to run at some speed, and it was taking some time. Right? We don't know what was the original speed, and then what was the original time it is taking. Right? But it was running at, let's say, some S1 speed and T1 time. Right? Now S1 into T1. This is the total distance that the train is covering. Right? So for example, we can write in distance in multiple combinations. Right? Distance. Let's say the distance is 200. 200. Then, if it is running at 20 kilometers per hour, then it will take 10 hours. If it is running at 40 kilometers per hour, it will take 5 hours. Right? If it is running at 100 kilometers per hour, it will take 2 hours. You can write anything like this. Right? But still, the total distance will always remain 200 only. Right? So, similarly, what we are saying, a train, it was taking some time t and it was running at some speed s. Now, with the new speed is 5 by 6 of the original speed, and the new time is t plus 10, 10 plus 10 of the original time. Then also the distance is same, right? So you solve this one and then you will get T1 is equal to 50, T2 is equal to 100. T1 is the original time it is taking and T2 is the new time, 10 minutes more that it is taking. Cool. Next one. If a man walks at the rate of 5 kilometers per hour, he misses the train by 7 minutes. However, if he walks at the rate of 6 kilometers per hour, he reaches the station 5 minutes before the arrival of the train. Find the distance covered him to reach the station. If a man walks at the rate of 5 kilometers per hour, he misses the train by 7 minutes. Okay, so here the distance between the man and the station is the same, right? The distance is not changing. That the time and the speed is changing. Whether he walks at 5 kilometers, he walks at 6, he walks at 10, he walks at 50, whatever. That is changing. If he walks at 10, obviously the he would be faster to reach than when he was walking at 5. Okay, so the distance is same. Let's assume if he was walking at t, then he will be exactly on time. If he was walking at t, we don't know what is the t, right? The t, then he will miss the train by 7 minutes, or he will be early by 5 minutes. But somewhere at some speed, he will be right exactly to the point where the train is arriving. Right? Let that be t. Let that be t, and let some that speed be some s. Okay, so at some speed, if he is walking for some time t, he will exactly arrive when the train arrives. Right. Now, what he is saying, if he is 5 kilometers per hour, then he is missing by 7 minutes. Right. So then t plus 7 into 5. T was the time at which he reaches. If t was the time he will reach. If he is working at some other speed, which where he will reach the train exactly when it arrives. Right. So T into S is equal to T plus 7. He's taking 7 minutes more at 5 kilometers speed. T plus 7 into 5. Or he's taking 5 minutes less because he's reaching 5 minutes early. 5 minutes less if he's walking at 6 kilometers per hour. So T plus 7 into 5 is equal to T minus 5 into 6. That means T equal to 65. Okay, so t is equal to 65 minutes. Ideally, everything we have to multiply in terms of hours. T plus 7, 7 minutes. So here ideally it should have been t plus 7 by 60 and t minus 5 by 60. This is hours and this is speed, right? So time into speed. But because anyway we can cancel 60 and 60, I mentioned it directly as t plus 7 5 into 5 equal to t minus 5 into 6 because 60 and 60 we can anyway cancel, right? But otherwise the distance is actually speed in hours into, sorry, speed in kilometers per hour into time, which is in hours. Okay, anyway 60 will get cancelled, so t is equal to 65 minutes, right? T is equal to 65 minutes. Now what is he saying? Find the distance covered by him to reach the station. We can substitute this t in one of these, right? One of this is t plus 7 into 5. Let's say 65 plus 7 into 5, 72 minutes into 72 minutes into 5 kilometers per hour. What is 72 minutes? 1 hour 12 minutes. 1 hour 12 minutes is 1.2 hours. 1.2 hours equal into 5 kilometers per hour, which is 6 kilometers. 6 kilometers distance. Okay, for 6 kilometers distance, the distance between his location and the station is actually 6 kilometers. And to travel and he's taking 65 minutes. Sorry, 65 minutes to travel 6 kilometers. That means what is the speed? 65 minutes is equal to 1 hour 5 minutes, right? 1 hour 1 hour 5 minutes is equal to 1 hour 5 by 60, 1 5 by 60 hours. Right, 1 by 12 hours. Okay, that is the time he is taking. Time is equal to 1 by 12 hours. Okay, so 13 by 12 hours he is taking. And what is the distance? Distance is 6 kilometers. So 6 by 13 by 12 is the is the speed, right? 72 by 13. 72 by 13 is equal to roughly 5.5 kilometers per hour. So if he's traveling at roughly 5.5 kilometers per hour, he will reach in 72 minutes. Okay, 72 minutes. That is the time where the train will also reach. Right. Now, sorry. T plus 7 is equal to T is equal to 65, right? So T equal to 65, 1 by right. 70 per day. So he will reach in, if he's traveling at 5.5 kilometers per hour, he will reach in 65 minutes. And if he's traveling, or if he has slowed down, instead of 5.5, if he travels at 5, he will reach in 72 minutes. 72 minutes, right? 72 minutes versus 65 minutes. 65 minutes 7, he will be 7 minutes late. Otherwise, if he is traveling at 6 kilometers per hour, right? 5.5 versus 6. If he is traveling at 6 kilometers per hour, then he will reach 5 minutes early, right? So 6 kilometers is the distance, and he will travel 6 kilometers per hour. Then he will exactly reach in 1 hour, which is 5 minutes lesser than your 65 minutes. Earlier he was taking 65 minutes, right? Which will be 5 minutes lesser than 65 minutes. Right, hope you understood the problem. The distance is same. The distance is same. So we'll assume at some t, he will reach exactly to the point when the train is arriving. We don't know what is the t, what is the s. Doesn't matter. So plus t plus 7 into 5 would be equal to the t minus 5. The t minus 5 is at a higher speed, the lesser time that he is taking. Next one. I walk a certain distance and ride back, totaling a total time of 37 minutes. I could walk both ways in 55 minutes. How long would it take to ride both ways? Okay, what is he saying? Uh, I'm taking 37 minutes going up or going forward and coming backward. T1 plus T2 is equal to 37. Okay, so now if I walk both ways, I will take 55 minutes. Right, that means walking one way will take 27.5 minutes, right? Both ways 55, one way is 55 by 2, 27.5. So T1 is 27.5. What does that mean? T2 going forward, let's say, is 27.5. That means coming backward, T2 is taking 37 minus whatever is the additional amount, right? 37 minus 27.5, which is 9.5 minutes, right? So coming back, if I'm riding, I will take 9.5 minutes. If I'm walking, I'm taking 27.5 minutes. 27.5 plus 9.5, total is 37 minutes. Right. If I am riding one side, I am taking 9.5 minutes. Right. Now, if I am riding on both sides, how much will I take? 2 into T2, which is 2 into 9.5, which is 19 minutes. Simple, right? This is also easy problem. Next one. Sound is said to travel in air at about 1100 feet per second. A man hears the axe striking the tree 11 by 5 seconds after he sees it strike the tree. He's seeing it, but the sound he's hearing after 11 by 5 seconds. That means 2 point some seconds. Right. After 11 by seconds, 11 by 5 seconds. Right. He's seeing it immediately, but he's hearing after 11 by 5 seconds. That means the sound is taking 11 by 5 seconds to travel from the tree to him. Right, 11 by 5 seconds it is traveling. And each second it is traveling 1100 feet. Right, if each second it is traveling 1100 feet and 11 by seconds it is traveling, because it is traveling, then only he was able to hear. The sound has to reach him, right? It is taking 11 by 5 seconds for the sound to reach from the tree to him. That means what is the distance it is covering? It is 11 by 5 into 1100, which is equal to 2450. Right, 2450 feet is the distance between the tree and the man. Next, an express train traveled at an average of 100 kilometers per hour, stopping for 3 minutes every 75 kilometers. Every 75 kilometers, it is stopping uh, for 3 minutes. How long did it take to reach its destination? 600 kilometers from the starting point. Right, 600 kilometers it is taking. Right, 600 kilometers is the distance. Ideally, if there was no stops, it would have taken 6 hours. Right. And how many stops it will do? So every 75 kilometer, one stop. Right. Please note, it is not 8 stops. It is 7 stops only. Why 7 stops? 8 stop is not needed. 8 stop is destination. So for example, if it is 150 kilometers, 150 kilometers, it is 150 by 75 is 2, but still it will stop at 75th kilometer only. Right. So what are these 7 stops? It will stop if it is 300, 75, 150, the distance, then 225, then 300 is the final stop. Right. So it will stop 3 minutes here, it will stop 3 minutes here, it will stop 3 minutes here, and this is anyway destination, right? So we don't need to count 4 times. It is the waiting time is not 4 into 3. The waiting time is 3 into 3. If the destination is 300 kilometers, let's say if the destination is 600 kilometers, then at 600 you don't need to count, right? Then 300, then 3, 3, 3. Right. Total 7 stops only. 525, 450, 375. It is like this. Right. So it will have 7 stops only. It will not have 8 stops. Please note this. 7 stops of 3 minutes, because the total 600 by 75 is 8 minus 1. The final stop we don't need to wait. Right. Final stop is the destination. Right. So 7 stops. Each stop is waiting for 3 minutes. Right. So 21 minutes is anyway waiting time. And then the remaining part, it is traveling at 600 kilometers per hour. So for this 600 kilometers, it will take 6 hours plus 21 minutes of waiting time. So 6 hours, 21 minutes is the total time. Right. Next. A motor car starts with the speed of 70 kilometers per hour, with its speed increasing every 2 hours by 10 kilometers per hour. In how many hours it will cover? 345 kilometers. Every 2 hours it will increase, right? 10 kilometers per hour. So first 2 hours, what it will do? For the first 2 hours, the speed is 70 kilometers and the distance is 2 into 70, 240 kilometers. Next 2 hours, the speed will increase to 80, right? This 80. Next 2 hours, how much will it cover? 80 into 2, which is 160. So 140 plus 160, how much will be left? 45 is left, right? Total distance is 345. 45 is left. And now what is the speed again? 80 plus 10, 90. So 90 kilometers per hour is the speed and 45 kilometers is the distance left. So zero point 0.5 hours it will complete. So what is the total time? 2 hours plus 2 hours plus zero point 0.5, which is equal to 4.5 hours. This is very easy problem. Next one. A person travels equal distance equal distances with speeds 3 kilometers per hour, 4 kilometers per hour and 5 kilometers per hour and takes a total time of 47 minutes. What is the total distance? Okay, he travels at 3 kilometers per hour. Okay, what does that mean? Time, what does the time taken? Let's say the three distances are x, x, x. Okay, so what is the time taken for the first distance? X by 3, right? Time is equal to distance by speed, x by 3. What is the time taken for the second distance? Second distance is again x, that speed is 4 kilometers per hour. So second time is x by 4. Similarly, third time is x by 5. Now, x by 3 plus x by 4 plus x by 5 is equal to 47 minutes, is equal to 47 by 60 hours. So, x into 1 by 3 plus 1 by 4 plus 1 by 5 is equal to 47 by 60 hours. X into this again, 1 by 3 plus 1 by 4 plus 1 by 5 is equal to 47 by 60 only. X into 47 by 60 is equal to 47 by 60. That means x is equal to 1 kilometer. So, x is 1 kilometer. Then, but the total distance is what? 3x, right? 1 kilometer he traveled at 3 kilometers per hour. Second kilometer he traveled at 4 kilometers per hour. Third kilometer he traveled at 5 kilometers per hour. So total distance is 3x, which is equal to 3 kilometers. Next one. A farmer traveled at a farmer traveled a distance of 61 kilometers in 9 hours. He traveled partly on foot at the rate 4 kilometers per hour and partly on bicycle at the rate 9 kilometers per hour. The distance traveled on foot is what? Okay, very good. He traveled partly. We don't know how much time he has traveled on foot, how much time he has traveled on bicycle. Right. Let's assume that traveling on foot is T1 time and traveling on bicycle is T2 time. So, and the total distance is 61 kilometers. So, speed into distance of foot, that is 4 into T1. Right. 4 into T1 plus speed into time of bicycle. So 9 kilometers per hour into T2 is equal to 61. T1 is time taken on foot. T2 is time taken on bicycle. 4 kilometers per hour speed and T1 time. 4 into T1 is the distance covered by foot. 9 into T2 is the distance covered by bicycle. This distance plus distance equal to total distance, which is 61 kilometers. Now, this time, the foot time and the bicycle time is equal to total 9. Right, these two equations are given. Now 1 minus this equation minus 4 into second equation. We want to cancel out T1, right? That becomes 9T2 minus 4T2, which is equal to 5T2, is equal to 91 minus, sorry, 61 minus 4 into 9, 61 minus 36, which is equal to that 25. So 5T2 equal to 25, T2 is equal to 5, T1 is equal to, because T1 plus T2 is equal to 9, T1 is equal to 4. What does that mean? On foot, he traveled for 4 hours, 4 into 4, 16. Plus on bicycle, he traveled for 5 hours, 5 into 9 is 45. Right, 45 plus 16 is equal to 61. So distance on foot, how much he traveled? 16 kilometers. And distance on bicycle, how much he traveled? 45 kilometers. Total distance is 61 kilometers. A is faster than B. A and B each walk 24 kilometers. The sum of their speeds is 7 kilometers per hour, and the sum of times taken by them is 14 hours. Very good. A and B each walk 24 kilometers. The distance distance of B, both are 24. And the sum of their speeds, S1 plus S2. Let's say S1 is A, S2 is B. S1 plus S2 is 7. D1, D2, both distances are same, 24 kilometers. Right. Now the sum of their speeds is this one, and the sum of times T1 plus T2 is equal to 14 hours. What is T1 plus T2? The distance of A by speed of A plus distance of B by speed of B. Both distances are same. So 24 by speed of A plus 24 by speed of B. Speed of B is what? Speed of A plus speed of B is 7. So 7 minus speed of A is speed of B. So 24, the distance of A by speed of A, which is S1, by distance of B by speed of B, which is 7 minus speed of A, which is 7 minus S1. So 24 by S1 plus 24 by 7 minus S1 is equal to total time is 14 hours. So you take this thing out, 24 into 7 minus S1, 24 you take it common, plus S1 by S1 into 7 minus S1 is equal to 14. Then, then you then you simplify this. If you simplify this, S1 will get cancelled, only 11 left. So this only 7 left. This 7 goes 2 times in 14. This 2 again will go 12 times. So what will be left? 12 equal to this product 7 s1 minus s1 square. S1 square minus 7 s1 plus 12 is equal to 0. S1 square, we have to divide this into two parts so that the sum is minus 7 and the product is plus 12. Right. So minus 4 minus 3 will divide. So sum is minus 7 and the product is minus 4 into minus 3 is plus 12. So s1 square minus 4 s1 minus 3 s1 plus 12. S1 into S1 is minus 4. We just simplified this. Minus 3 into S1 minus 4. So S1 is equal to 4 and 3. Okay, we have got two equations. Right. So we have got two answers. Obviously, we'll get two answers because then we have to pick one. So we have got both the speeds. S1 and 7 minus S1. So 4 and 3. Because A is greater than B. The speed of A is faster than B. We have to pick one of them is A, one of them is B. Right, speed of A is 4 and speed of B is 3. Right, the total speed is S1 plus S2, which is equal to 7. You understood this, right? A is faster than B. A and B each walk 24 kilometers. That means the distance of A, distance of B, both are same. And the speed of A and B is in 7 kilometers and time of A and B is 14 kilometers. So time 1 plus time 2, time A plus time B is equal to 14. Time A is distance of A by speed of A. Time B is distance of B by speed of B. Both distances are 24 only. 24 by speed of A plus 24 by speed of B, which is equal to 7 minus speed of A. 7 minus S1 is equal to 14. Then we simplified this and we got two solutions. S1 and S1 has got two answers. So we could, if it was not given, A is faster than B, then we could have chosen either one of them as 4 and 3. But here it is given A is faster than B. So that means A has to be 4 and B has to be 3. Right? Hope you understood these problems. We'll pick up more problems in the next session. So the thing that you have to remember is only one formula, that is distance is equal to speed into time. That is only one formula, and then you have to use that formula, that concept in multiple formats. And I think this concept, you please try to understand this concept when it is given. So for example, let's look into this again. Walking at 5 by 6th of its usual speed, a train is 10 minutes too late. Find its usual time to cover the journey. Here what we are trying to do, here a train, it would have taken some time t to arrive. So it was too late, right? So it would, we don't know how long does it take. The train might take 30 minutes, the train might take 50 minutes, whatever it is. Now, let's say the train takes generally 30 minutes. At 30 minutes, it runs at certain speed, right? Now, if it is at certain speed, let's say 30 minutes. Now, if it is running at 5 by 6th of that speed, then it is taking 30 plus 10, 40 minutes. Right. We don't know whether it was 30, whether it was 40. We don't know whether the speed was 50 kilometers per hour, 80 kilometers per hour. It doesn't matter. What it is just saying is, if it is doing 5 by 6th of the original speed, it is taking 10 minutes more than the original time. Correct. Which is what we are doing here. Original time, let it be T1, and original speed, let it be S1. Now, the distance covered. In both the cases, the distance is same, right? The distance, whether it runs at 25 kilometers, it runs at 50 kilometers, still the distance has to be same. Just that the time it will take will go here and there. So for example, I have to go 300 kilometers. Whether I travel at 30 kilometers per hour, 50 kilometers per hour, 100 kilometers per hour, I will still reach the destination. The only thing that will matter is when. Whether I will take 1 hour, I will take 5 hours, I will take 10 hours, whatever. Right, the time will change, but the distance will always remain same. So in this case, the train still has to travel the same distance, whether it runs fast, it runs slow. In this case, say, so that's why the time, whatever it is taking into original speed is equal to the time in the second case, whatever it is. The second case is 10 minutes more. So T1 plus 10 into second speed is 5 by 6th of S. We simplify these equations and we get T1 and T2. These kinds of problems, you have to find out what are the two comparative uh, equations that we can write. Which two things can be compared? Which two distances are equal? Which two times are equal? Which two speeds are equal? That kind of equation we should be able to write. Here also it's the same thing. Here he walks at 5 kilometers per hour, he misses by 7 minutes. Right. That means at some time, with some speed, he will not miss. He will just arrive at the right time with the right speed. And let's assume what is that time? That time as t. Now, at some speed, we don't know what is that speed. Doesn't matter for us. Now, that time plus 7 minutes. He's taking 7 minutes, 7 minutes more if he's walking at 5 kilometers. So that time plus 7 minutes into 5 kilometers. That time plus 7 minutes by 60 actually. So this is the total number of hours. Is equal to that time minus 5 minutes because he's reaching 5 minutes early. So he's taking 5 minutes less to reach. So in less 5 minutes lesser, that is t minus 5, and speed is 6 kilometers. He's still able to cover the distance. So by 60 by 60 will cancel. We get it as t equal to 65. That means at t equal to 65, you will catch the train. So the train, that means the train is coming in 65 minutes from the point where he is. So he has to reach that station exactly in 65 minutes. He has to reach the station in 65 minutes. That means he has to travel at somewhere around 5.5 kilometers per hour. And if he travels at 5 kilometers per hour, he will miss the train by 7 minutes. If he travels at 6 kilometers per hour, he will reach exactly within 1 hour. Okay, the distance, the distance in this case is 6 kilometers. If he's traveling at 6 kilometers per hour, he will reach exactly in 1 hour. That is 60 minutes. If he's traveling at 5.5, he is reaching in 65 minutes. That is what his usual speed is, and he'll just catch the train. But he's traveling at 5 kilometers per hour, he will reach in 72 minutes, which is 7 minutes late. He will reach in 7 minutes late. Right. So what is his ideal time? Ideal time is 65 minutes. 65 minutes if he walks at 5.5 kilometers per hour. If he walks at 5.5, I'll write it here. If he walks at 5.5, he will take 65 minutes. If he walks at 5, he will take 72. If he walks at 6, he will take 60. Right. This is 72 is 65 plus 7. 7 minutes more. And 60 is 65 minus 5, which is 5 minutes less. So all three combinations are same, right? If he's walking 12 kilometers per hour, then it would be half, right? 6 kilometers. The distance is 6 kilometers. 6 kilometers. If he walks at 12 kilometers per hour, then instead of 60 minutes, it will take 30 minutes only. Right. So zero point 0.5 hour. Then you'll take 30 minutes only. Likewise. So you just need to know how to write these equations. When distances are same, what is the speed into time? Which speed into time equal to which speed into time equal to which speed into time. Right. Hope you understood these problems. We'll pick up more other important problems. All the problems that I picked are really important for you to get conceptual clarity. The kind of questions that we are getting in the exams. These are all previous questions only. We need to understand how to solve these equations. Anyway, if you have any doubts, please comment and please reach out. We'll discuss those. Okay. Bye bye.